Welcome to this section on working with web calls in Xamarin.iOS. The first thing we're going to look at is something that was introduced in iOS 9, and that's App Transport Security. What it means, what it does, and why it's important to understand it. Then we'll have a look at low-level HTTP web requests. If you want a lot of control over your web requests, then you should go this route. Alternatively, if you don't want a lot of control and you just want to write a few lines of code, I'll walk you through how to use the REST-sharp component, which also includes an automatic JSON deserializer if you need one. When we make web calls on iOS, we first need to note the security of our calling website. Now, what does this mean? Well, at a very basic level, this means, does the website use a secure certificate? So does it begin with HTTP or HTTPS for secure? In iOS 9, Apple introduced a concept of App Transport Security. It also introduced it for applications on OS X. Now, App Transport Security ensures that you are connecting to a secure connection. And if you're not, your connection will throw an error or just simply not work the way you expect it to. So there are several options for getting around this if you don't have a secure server to connect to. Let's find out what they are by creating a new solution, single view app, and let's put this as web requests. And we're going to set our app transport security inside of info.plist. And if we scroll down, you'll notice there are no actual values for app transport security, and that's because we have to edit the source. We have to add a new entry. So double click and then double click the custom property and enter ns app transport security and make sure that casing is correct. Now this is a dictionary because it's going to hold all of the values applicable to transport security. If we add a new entry to this dictionary, we have several options. The first option you should consider is adding your domain as an exception. So you can have ns exception, and I believe it's domains. And you can add an array of domains that allow you to connect to them without them being secure. But if you're making an app that, for example, loads arbitrary websites, so I've made an RSS feed reader app a while ago, then you're going to have to disable app transport security completely. You should only do this if you really have to, because insecure connections, as I'm sure you know, can compromise any data sent over them. So to disable them, we type ns allows arbitrary loads. And this is a Boolean, and the default value is yes for this. So save that info plist. Now your app has access to the internet completely unfiltered by App Transport Security. The very first web connection that we're going to create is at a lower level, so we get a feeling for what's happening in it. We're going to create an HTTP web request. So inside of our view.did_load in our view controller, let's have var request is equal to a new, or rather not a new, this is an HTTP web request, and I haven't added my using yet for our system.net. And we're going to create, and it requires a URI string. Now this is going to be a literal string, so we just want to have an before our open quotes to make sure it doesn't change anything about our string. And let's use the example address that Xamarin provides on their documentation, which is rxnav.nlm.nih.gov, and then we have /rest/rx terms sorry, this is so long, rxcy/198.440/all info. Right, I believe that should now be correct. So we've created our web request. Then we can set an optional type for the content. So request.content type is equal to, and this takes a string, so application, and I'm expecting JSON back from this. And then we need a method for our request, and this can be get, because we're retrieving information. If we were putting information out there, we would have post, but we are retrieving it, so get it is. Now the following block of code is going to look at actually retrieving the response from this server and printing it out to us. Typically, HTTP requests will take a fair amount of memory, especially if you're receiving a whole lot of text back. So what we want to do is put these in a using statement so that the memory is automatically freed up once we're done with the statement. So let's have a using HTTP web response, and we will call this response is equal to our request dot get response. So this fires it off, and then we have to cast it as an HTTP web response. So let's open our braces, and let's write some of the code that we need inside of this using statement. The first bit of code we need is to check our status code of the response. I'm sure you've seen on the internet when you browse somewhere that a page doesn't exist anymore, you get a 404 error. Well, these status codes are things that are well understood and well defined, and they are plumbed into our HTTP or our system.net class. So we can check if response.statusCode is not equal to the HTTP status code dot OK, and you'll see how many options we have here for codes. Then let's give ourselves a message and say console.writeLine status code bad or not OK. But if it is OK, this if statement won't execute, and we can then use what's called a stream reader to actually get the response stream for us. So using our stream reader, which we don't have yet, stream reader dot right click it, resolve using system IO stream reader, and we will call this reader is equal to a new stream reader, and it asks us for the stream. So we grab this from our response.getStream, and of course we have some braces for this method too. Let me just check I've closed my brackets. I have one short here. There we go. Okay, so now we have our data coming back using this reader. Let's create a string out of it. Var content equals reader dot read, and we can read various things, but we want read to end, which provides us a string. Then let's check that string if string dot is null or white space, and then let's pass it over our content, and this just checks if it's empty or non-existent. Then let's give ourselves a message, console.writeLine response string invalid, else we have a legitimate response, so let's have console.writeLine and let's have response and actually print out the text that we have retrieved, so content. Okay, that should just about do it for our web request. So it's going to create it, set the content type, use the method get, it's going to check for a response. If the response code is okay, then it's going to carry on using a stream reader. If the string that it pulls out of the reader is okay, then it's going to give us the response. So we have a fair amount of error checking and exception catching in here. But by no means have we covered all of our bases in terms of errors or exceptions. So let's hit play. Oh, just before I do, you'll notice this HTTP doesn't have an S, so it's not secure, and that's why we set our app transport security previously. So hit play, and this will go and get our data and hopefully print something out to our application output. There we go, it's now running. Let me open the app output and let's wait for it to do its business. And there we have it. Right at the top we have our web requests response, and actually this is providing an XML file back, as you can see from the formatting there, not a JSON, so Xamarin's documentation isn't quite right. Okay, so we have all of our data passed over and we have received it. So I'll just stop that running, and that is the conclusion of creating a low-level HTTP web request when you want to really control what's going on. In the last lesson we created a simple HTTP web request, and I've now moved this into its own method, and I've cleared out my view.did_load. And that's because we're going to try using a Xamarin component that does all of this stuff automatically for us. So let's open up our components, get more components, and the component we're looking for is a very handy one called REST sharp. REST sharp. And this is a simple client for consuming HTTP APIs. You'll notice in features it's got this very handy automatic deserialization of XML and JSON. So previously in this course we've looked at the JSON.NET library, and I think this uses the JSON.NET, but don't quote me on that. But it's handy that we have it automatically set in here. We can also have OAuth, various security items. Right, let's add this to the app. Let it finish downloading, and it gives you a couple of examples in its documentation. So let's do this slightly differently. Let's grab this text that it suggests we should try out, copy it, and then let's pop it into the view controller, view.did_load. Right-click REST client, and let's use REST sharp. Okay, so this is Xamarin's example site for grabbing a feed of some sort or some data. What it does is it creates a new REST client, then it creates a new REST request, and it formats a string, and this is just a fancy way of actually creating this address that we created in our old HTTP web request. Then it executes this request asynchronously. And that means that this will run, but immediately it will continue to the next lines. It won't wait for this to finish before it carries on writing or carries on executing. Then once this is executed, it will then come back here and run this section. So let's hit play, and hopefully we should get the same sort of result in our app output. And there we have it. And now we actually have a JSON output from this. I'm not quite sure why in our HTTP web request previously we didn't have it, so maybe that's one for you to look up. Why have those two methods provided different responses? Okay, so that is basically how you use REST Sharp. Now, as I mentioned before, REST Sharp also gives you the ability to deserialize JSON data. And I believe this is one of the more searched for examples out there on Xamarin that don't really exist in plain English. So I'm going to create one here for you. Let's remove this client execute async and replace it with var response is equal to a new, oh, not new, this should be client dot execute. We're not going to do this asynchronously. And then this execute requires a class that our JSON is going to be deserialized to. So let's go ahead and create a simple class. I'll just comment this out for now so it doesn't mess up my formatting. Let's have a public class item. And inside of here we're going to have a public string, and this string is going to be called the root element of our returned JSON. So for this address we're using the root element is rx terms properties. Let's have a getter and a setter for that. And that's all we'll do for this class because we don't need to do anything complicated right now. So uncomment our var response, and now we can pop our item class into there. Then what do we need? We need to actually pass it over the request. And then once we have that request, we can have the console.writeLine, and we want our response.data is where it holds the deserialized data. You'll notice this is now of item of class type item. And then we can pull out our rxTerms properties from there and show it. So I'm going to hit play, and this is going to give me some output that grabs that root element and then prints out all of the text underneath it. Now this is a bit difficult to see as it currently stands, and what I've done is load up the original JSON that's output from that address that we're using, and you'll notice the root element is this rxTerms properties, and that is precisely the root element we've defined inside of our item class. And then what we're seeing in our application output is simply this rest of the text minus the rxTerms properties, because we're setting that as our string. Okay, so that's how you really easily and simply deserialize JSON, and it's also how you use the REST Sharp library, which is also available on other .NET platforms. Congratulations, you finished this section on working with web calls in Xamarin.iOS. First, I showed you how to use app transport security and set it inside of your info.plist file. Then we looked at creating our very own low-level HTTP web request that allowed us to have a lot of control over the web request parameters we may want to set. Finally, I showed you how to use the REST-sharp component that allows you to make web calls with just a couple lines of code. It's very useful if you don't need extensive functionality through HTTP web request. It also includes a handy component that allows you to deserialize both JSON and XML on the fly.